So what we recognized from our example at the beginning, when you have multiple transformations, and if you write it y equals, so I'm just going to move that k over to the other side. Notice that they wrote it in factored form. Okay? When you're going to do all the transformations to make what they've written here much simpler, all we need to do is go from left to right. In other words, you will always do your stretches, compressions, reflections first, then the translations. That's a much easier way of remembering it rather than they give you this formula to remember. X over B plus H AY plus K. If that is easy for you to remember, maybe you had a dog named Explicit, and then it's like, oh, that's the same as my dog's name. And I totally am going to remember that. If that's your case, but I think for most people it's going to be easier if you just think, oh, I just have to go from left to right. That means I'm going to do all my stretches first, then my translations. And when you set up your points and the arrows, you'll have two sets that way. So when we go to example 2 here, we can see this happening. First of all, they give us the graph of f of x. Things are in function notation. It says sketch the graph of, and they have that 4 on the other side, so I'm just going to rewrite it. With the 4 on the other side. Okay? Do you notice how I drew my brackets? When I have brackets inside of brackets, I have a small set of brackets and a big set of brackets so that you can visually see which ones go together. That can help you a lot in your notes. Okay? Going through this, can you see that it is already in factored form? The 1/2 has been factored out. So when we go to label things here, the 1/2 is going to be vertical or horizontal? Horizontal. Stretch or compression? Stretch. You're going to multiply your x values by 2. The +1, that's going to be a horizontal translation. You're going to go 1 to the left. And the -4 is going to be a vertical translation. You're going to go 4 down. The other thing in this graph, they didn't label them. On your exam, they would label these on your graph as well. There are 2 asymptotes in this equation, x equals 0 and y equals 0. So I'm going to set this up, stretches first, then translations. I'm going to take some points from my original graph. I really like 1, 1 and -1, -1. That's 1 point from this part of the graph, 1 point from this part of the graph. I know they labeled 2, 0.5, and you could use that, but it has decimals. And maybe I'll want to just try to work with whole numbers. So I think 1, 1, and -1, -1 are nicer points. We're also going to find out what happens to the 2 asymptotes, y equals 0 and x equals 0. But to start off with, we're going to get our setup. Stretches and compressions and reflections first. Can you see we only have the one stretch? So above this arrow, I'm going to write x by 2. We have 2 translations, so above the second arrow, I'm going to write both of my translations. 1 left and 4 down. So x by 2, 2, 1. I do a quick check. Yes, I did the right coordinate. Second one, -2, -1. Quick check. 1 left. Okay, so this will go to 1. This one will go to -3. 4 down. This will go to -3. This will go to -5. Again, quickly checking it. Now, for our asymptotes, They're both at 0. Can you see when you multiply something that's at 0 by any number, it's still going to be at 0? The only thing that's going to change your asymptotes, if your asymptotes are at 0, the only thing that's going to change them is translations, up, down, left, or right. If I go 1 to the left, think about both your asymptotes. Can you see it only affects the vertical one? Going 1 to the left, it will now be at x equals -1. And that makes sense because the 1 to the left changes an x coordinate. That's your equation. That's x equals. So it's changing x equals -1. Moving 4 down is going to change your other asymptote to y equals -4. I find when you have graphs with lots of stuff like asymptotes that are busy like this, it's actually going to be much easier to draw your new graph separately. So I'm going to set up my axes here. And I'm going to graph x equals -1 and label it. Y equals -4 and label it. Then the 2 points that I found were at 1, -3. And -3, -5. Once I have those 2 points and my asymptotes and I know the shape of my original graph, I can draw my graph towards my asymptotes, and now we have our final graph. So to review, what did we do? We labeled what was going to happen. We worked from left to right, doing our stretches, compressions first, then our translations. This graph had asymptotes, so it was important to look at what happened to the asymptotes as well. And once we had our new points and the asymptotes, it was easy to graph. Okay? I'm going to add a part B to this one. Write the explicit equations for each graph. So to start with, our original graph, they gave it to us in function notation. So it could have been anything. It could be something that we don't know. But this is a graph that you know the equation for. What graph was this one? As an explicit equation, this was y equals. This one was recognize it as the 1 over x graph from the colored papers. So in other words, they're telling us that the regular function here is 1 over x. And we also want to find, so we had our regular function, the original was 1 over x. How would you write the blue one that we drew, which was y equals f of 1/2 x plus 1 minus 4. So again, we're just really practicing working with function notation. How does function notation work? Well, function notation says whatever you plug in goes where the x is. Now what are we plugging into the function? We're plugging a 1/2 x plus 1. All of that is inside the function. How would I write that? Not in yellow. I would write y equals 1 over, it's normally 1 over x, but now it's going to be 1 over 1/2 x plus 1. Yeah, an explicit equation doesn't have the f in it anymore because the function notation has the f. The explicit equation is the actual graph. And then we still have a minus 4 outside of our function. Okay? So, and the reason I want you to see this is because the textbook almost always gives you a graph to begin with and graph your new function. Okay? But some of the questions you're going to be asked will be just graph this. And that's the only thing the question says. If you get that question, you have to be able to recognize, and I think this is the hardest one to recognize, that this is a 1 over x graph with extra numbers. Can you see there's an extra number out front, there's an extra 1, there's an extra minus 4. So you would draw this on your own with the asymptotes and labeling 2 key points, 1, 1, negative 1, negative 1. Then you would have to be able to recognize that this stuff is where the x was, so this is the inside of the function. This is a horizontal stretch. X by 2. This is a horizontal translation, 1 to the left. And this would be a vertical translation, 4 down. But that would make this same question a little bit harder, right? Because you'd have to be able to recognize the graph. And I think the 1 over x one is the hardest one to recognize. Yes? And the asymptotes that are at 0 are only affected by translation. If you had a graph that had an asymptote at x equals 2, and you multiplied x by 3, it would make it at x equals 6. So there are cases where asymptotes could be affected by stretches, but all of the parent graphs that we have that are going to have asymptotes this year, all of those asymptotes are at 0. So for our graphs, the only thing that's going to affect them is translations left, right, up, and down. Okay? Try 7 and 11.